My name is Sebastian, born and raised in Munich, Germany, and I work for this company called IBM. And I do a lot of Java things typically. So here you see a lot of Java titles involved, and in general I'm a lot on the enterprise Java space. So specifically what I want to talk about in this presentation is whether there is such a thing as a modern enterprise Java. Just a quick poll, who of you uses Spring? Hands up. Okay. Who of you uses Java Enterprise like Java EE or J2EE or these technology? Okay, a few of you as well. So what I want to show you is how a modern enterprise Java thing looks like, and that there is actually such a thing. So what I want to start with is Java EE, how I call it the goods parts. And well, first of all, now you could replace Java EE with Jakarta EE, but let me start with what is included here. So Java Enterprise comes with a lot of history, a lot of legacy, and a lot of stuff included. If you look into the Java EE platform, that's huge, right? So this is why I compiled some list with typically used components in modern projects, which I call the good parts according to me. So they come with APIs that developers typically know and that they're very productive to use. Things like CDI, JAX-RS, JSON-B, JSON-P for JSON binding, right? JPA, even if you use Spring, you typically use that as well like servlets. JTA for transactions, for persistence, right? EJB, but only in the new version, right? Version 3, not the old stuff. Nobody wants to use that. Bean validation and a few other things, right? So these are parts that are, I believe, very effective and very usable to write modern enterprise applications that ship with Java EE. So you can have a look at the website. What was Java EE before, that is now Jakarta EE. So what is that? Jakarta EE, if you know, maybe Jakarta, like geographically, is the capital of the island of Java, right? You know, Java is an island, and Jakarta is the capital of that. Who of you have been to Java, to Indonesia? Awesome. Me too. I have not been to Jakarta, but close to that. It's a very nice island, by the way, if you want to visit it. So this is how Enterprise Java will evolve in the Eclipse Foundation. And that there is another thing that I want to show you, that is Eclipse MicroProfile. So MicroProfile is, well, what is it? Another type of enterprise Java. It basically, well, it comes with some history why it evolved. It came with a few companies that founded it, basically, when there was not much progress in enterprise Java. And it is a smaller subset of Java Enterprise components. It's actually built on the same technologies, such as Java Enterprise. And it also comes with, well, some new additions. So MicroProfile, if we have a look at it, what I now again call the good parts that are included, we see still some things like CDI, right? JAX-RS, JSON-B, JSON-P. So we see it's actually based on the same technology that we had in Java Enterprise, right? If you know how to use CDI and injection, if you know how to use JAX-RS, then you know parts of MicroProfile already. And it also comes with some other things, like MicroProfile config, fault tolerance, metrics. These have been added for modern microservices, right? Like for modern cloud-native technologies, you would need these concerns to just address that, well, to solve these concerns in a little bit more pragmatic or effective way, right? So to give you some overview, one last slide, and then I don't like slides too much, then we see some live code. To give us some overview here about the Java EE and MicroProfile story, you see Java EE comes with a lot of technology, but there's a lot of intersection with MicroProfile, so it's actually based on the same technologies. And well, Java EE will evolve into Jakarta EE into the future, so that's going to be interesting, and then we see whether some standards will be merged. The good news is that now we can use some technology that actually enables us to use both. And this is what I want to show you as a modern enterprise Java approach. So here we go. Now finally, let's have some code. And what I will show you is some, well, I like coffee. So I was especially excited about, I think this is the coolest jug name that you could come up with, CoffeeJUG. And I'm also happy that I'm now here in Coffee Central in Ukraine. So I'm very glad about that. And of course, I have some coffee example, right? So this is a coffee shop example application to, order some coffee. And what I will show you is a sophisticated or opinionated way how to build up modern projects. And I think that's a quite important topic, because when I come into projects, into real-world enterprise projects, it starts already with the Maven or with the build description. It's usually huge, right? Hundreds and thousands of lines of XML, and nobody knows why this and that Maven plugin is there, and it's just too overwhelming, and the build takes a long time and things like that. So this is a very important topic, I believe, to keep that simple and to keep that modern. So as you can see, I use Maven to build my project. Who uses Maven? Yeah, most of you. That's what I thought. I built that project using a WAR packaging approach, and there's actually a reason for it. And just because I'm brave, I use Java 12. Who of you uses Java 12 in production? Nice, very good. Who of you uses Java 13? Well, I shouldn't. I have to update it. I shouldn't raise my hand. Okay, who uses Java 11, 10, or 9? Okay, and the rest, who uses Java 8? Yeah, I guess. Okay, well, you can give it a try. It works. And that's pretty much it. And what is very important, I believe, is that all the dependencies that you use in your production, in your main scope, are provided dependencies. So that is important for the build later on. That means, well, you don't ship anything into your artifact. But now what I want to show you is just some very quick walkthrough through the code that for now only uses Jakarta APIs. That is mostly CDI and JAX-RS. So what I will show you is, well, I have some application where I can order some coffee. I typically do this via HTTP, like this will be REST-like communication using JSON via HTTP. So I have something like a URL/orders where I can see the coffee orders, right? This is a JAX-RS resource. If you're into the Spring world, this is very much like a Spring REST controller. So at path orders, then I have this URL where I can get some orders like this. I can get some orders in JSON, or I can create some orders by ordering some coffee, right? That means I create some coffee order, and there we can already see that as a POJO, so this will be some declarative mapping using JSONB. So I have some coffee order and a few annotations here, how to map, well, what is a coffee order? It has a coffee type, right? Some espresso or whatever you want to have. And then we inject our business component, our coffee shop, injection, CDI here. And then well, it doesn't do much, order some coffee, and there will be stored somehow, and that's basically it. So the code on this side is not too exciting, but that is basically a way of using this modern approach. Okay, now let's see this in action. This is just a very basic example. Let's build this. I have the project right here. This is my command line. And then how do I build it? Well, I typically use Maven clean install or Maven clean package. Why do I use Maven clean package? Well, I'm used to it, so Maven package, some people are quite enthusiastic about it. Maven package would also be sufficient. And then I use this to build my project, right? So depending how fast my machine is, well, it's not too fast. It should be 1 second, but now it's 2 seconds for a Hello World project. That is already an important part. Your build should run fast, right? If it takes much longer than this, I would ask, why does it take much longer than this, right? In Java, we have a super fast compiler. I mean, these are just a bunch of classes, but I mean, it shouldn't take too long, right? Even if you have hundreds and thousands of classes, it should run in a few seconds. So if your build takes much longer than this, we need to talk. Okay, now I have my deployment artifact. In this case, I use a WAR file. Why a WAR file? Well, that's a standard way to deploy it. But what I really care about is that it's a thin deployment artifact. So this is 12 kilobyte. And if we have a look at it, it only contains the classes I'm writing here. I'm including like my coffee order, my coffee shop, and so on and so forth. But no implementation, no external third-party dependency. Why? Well, that has a lot to do how I build my project. So first of all, the Maven build is then super fast because it doesn't need to copy megabytes back and forth. And the other thing is, well, how I actually deploy this. So who of you uses Docker? Docker containers to run your workload. Okay. You might know about this, otherwise just ask. This is a Docker file. So the question is, how do I, in year 2019, ideally deploy my applications? If I have this deployment artifact, my Java classes, then of course I also need some runtime, right? So that means I need to go and download Java, I need to go and download a runtime that executes this Java enterprise, right? And then I can deploy it. Now I can go and do this locally on my machine, but then the question is, well, how do I run it later on in production? And that is the point where containers help us a lot because they simplify things. We can automate and we can well define in an infrastructure as code way how our deployment should look like. So what we do in this Docker file, we provide some steps what the installation should be, right? So instead of saying go and download Java, then go and download my application server, I use OpenLiberty here. What we do instead, we say, well, use this base image that already includes what I need, my runtime, the Java, some operating system configuration, and now include some configuration here, and of course our deployment. And that's it. Now, the good news is, Docker build. If you use Docker, you probably have seen that before, so I will build a Docker image, coffee shop. The good news is this runs fast. Why does it run fast? Well, that is how Docker works internally. All of these steps that you saw will result in so-called image layers of the copy on write file system image. So a copy on write file system, as the name suggests, it doesn't change state of your file system. It actually only copies and references the state once you have changes, right? So you actually, like in Git, you have append-only status changes in your file system, or in this case, in the whole image. And that means you're not really doing any work unless you have some changes. So in this case, what I typically change when I have some new code is, well, only my code, my application, my packaged application that contains my code classes, right? I don't change the Java version, I don't change the application server or any implementation. So the point is, if I now run this again, then it runs super fast because it actually doesn't do anything. It only changed what has been changed, actually, which in this case is nothing, and I can use some changes. I can use some caches. Okay, the same is true. Let's build this differently for my username, so I can use the public Docker hub. The same is true if I push something to a Docker repository, right? Docker repository is like a nexus for Java artifacts where I can store Docker images, right? If you know about Docker images, you might know they can get quite huge, right? It's basically a packaged, not an operating system, but a form of running your workload, including Java, including all kinds of things that gets hundreds of megabytes in size, right? But the point is, thanks to this layering approach, you actually can optimize things. And in this case, the Wi-Fi is not the fastest, but it still works because we're only pushing 17 kilobyte. Not 400 megabyte, but a few kilobyte. And the rest, well, the layer already exists. I had this base image before, so it didn't change. I don't have to do anything. And then it's just fast. So that is another reason why I want to optimize my Java builds artifact to only include, provided dependencies. So in other words, if I have some external dependencies, third-party dependencies that I really need for my business logic, well, then I also will provide them as provided scope and then include them somewhere here and add it to, for example, the application server lib directory. And I don't want to include it in my artifact because otherwise, I have one artifact that gets megabytes in size. And then I always have to rebuild and retransmit all of these megabytes where 99.9% doesn't change, right? Because you typically don't change the used framework, you change your code, right? So, oh god, TLS handshake timer, let's try this again. And then you can push this quite easily, even if you have a slow Wi-Fi. So I kid you not, I used mobile tethering before, and I used an airplane Wi-Fi to do a Docker push. If you have a thin deployment artifact, that works, right? Because, well, it's just tiny. It was a few kilobytes. So any questions to that, actually? I mean, this should be a quite open format. If you have some questions anytime, please feel free to interrupt me and just ask. Otherwise, well, we finally run our application. So we typically run our Docker images by Docker run, or in this case, Docker run and the port 9080, that is the default port for OpenLiberty, and we say CoffeeJUG, yes. And then we start, well, in this case, OpenLiberty with Java 12, and it starts this server. Okay. And then if we remember, we can finally go and order some coffee here. So again, that's about it, about building the project. What you see is a lot of test dependencies. These are okay in the test scope if, for example, this is JUnit 5, or in this case, Mockito, S or J, and then I have some JAX-RS for my system type of smoke tests, which I will show you in a little bit, but no compile time dependencies. And plugins, well, what I do down here, I unfortunately have to redefine some plugin versions. Typically, or ideally, this should be empty, this section, plugins. Why? Well, since I use Java 9 and newer, I have to respecify some version of the Maven plugin because, well, per default, it takes an older version that has issues. But I don't want to specify other plugins, right? So if you find yourself having a complicated Maven build and plugin definition with, you know, hundreds of lines of code of XML, I believe this is too cumbersome and it takes too long. There's probably a faster way around it. Even if you do things like Docker build in your Maven, right? Like the Docker Maven plugin, I believe is actually faster to call it just on the command line directly and not let Maven build the whole world. All right. Once my application is fully up and running, I can go to curl localhost. Then I go to coffee shop, if I can type shop. That is the context name because of the war file, right? coffeeshop.war, and resource orders. And then it says, great, 200, OK, and empty JSON array. There is no order in the system. OK, well, it's stored in memory, so that's why. And now if I want to create some new coffee order, I have to post some application JSON, what you saw here, right? And I have to post some coffee order with, well, in this case, it's a type. And I want to order some espresso, if that's OK. Let's do this. OK, good news. HTTP 201 created. So now apparently there is an order in the system. Let's see. OK, this looks good. A new espresso with some URL. Great. OK. So the Hello World example worked. I have now some order in the system, and I deployed my application. OK, let's include a few more things. So what I told you before, we have some more technology that we need, especially if we are into, well, a more modern approach with microservices in a cloud-native deployment world where you want to use some features that are not quite there yet in Java EE or Jakarta EE, things like we saw in MicroProfile. For example, you know, injectable configuration or resiliency that is easier to include, or, you know, metrics, health checks, and so on and so forth. And for that reason, I actually have two dependencies here, and these are the only two in typical projects that I want. That is Jakarta, and that is MicroProfile. These two are somewhat umbrellas dependencies. They come with a bunch of APIs and specifications, for example, CDI, JAX-RS, and what you saw. And MicroProfile includes a few others that I want to show you now that have some advantage. And another thing you might have noticed, I actually used some plugin for Liberty. Typically, I'm not a big fan of extra Maven plugins, as I told you, but that plugin actually has a nice killer feature that I really like. It comes with a development mode that enables me to, well, develop and operate a little bit faster, right? Because if I now would do some changes, right, I change some code, which I will do in a second, then I would need to rebuild Maven, right? rebuild Docker, and restart my container, right? Or start a new container, right? Which takes, it's quite fast. You saw Docker build like 2 seconds. Maven build like 2 seconds, Docker build half of a second, plus start, it's like, I don't know, 20 seconds. But this turnaround is too slow. Especially as we will see in the second session, you should care about automation and moving faster. So 20 seconds, way too slow. What I will do instead, I will run Maven liberty def, like this. Oops. And it will then start, well, a Liberty server in a somewhat development mode, which I can show you in a second. The nice story about that is it operates much faster than if I would rebuild and restart my application server every time I change something. So what I can show you now is some server features here. These are the features that I actually include in my runtime. So the nice story about Open Liberty, I'll show the website here. It's a modern runtime that supports both Java EE and Jakarta and MicroProfile. So we can mix and match some standards here, especially since both, well, are based on the same technology. So what I do here now is I want to write a little bit more code. And for example, I want to introduce some health check. So this uses MicroProfile health. That's the first thing I want to introduce, which is a health check for, let's say, a readiness probe, application scoped. So readiness, that is a readiness check. If you know about container orchestration frameworks, then you might know that term. It basically tells me this readiness check has to be valid, true, has to return, okay, I'm ready once your application is ready to do some work, basically once your application is up and running, right? So what I will do, health check response named coffee shop up build. So what it does, it includes some, well, basic health checking that now if I call my application curl will introduce a default endpoint under /health that tells me, oh, great, now I have a coffee shop and its status up since I included that, right? Why did it show up right now? Because while this plugin that works, it actually checks for file changes that I have in my project. So it knows about the Java Maven structure, and it says, oh, by the way, you just added a new class, so I have to recompile the source. And I quickly, well, the laptop seems to be under load. This should be less than a second. But I very quickly can restart that application that runs here. So it's like a very quick hot reload. So for example, if I say include some data, for example, hello world, then it would just quickly reload and say, okay, now this is included as well. Or, you know, goodbye world. And it will quickly reload that as well, and then it's updated immediately. That is just a nice story about this, you know, plugin of a more modern way, a faster way to update that, to reload that. Otherwise, I just have to wait, right? The alternative would be do a Maven build again, right? Do a Docker build, do a Docker run, and then after 25 seconds, I finally have the same result. Okay, any questions so far, by the way, for all the stuff that I showed you? Okay, then let's do a little bit more live coding. Let's include some other features. What I want to include is, let's say, MicroProfile config. That is injectable configuration. You might have written something yourself if you do enterprise Java. It's like basically I want to be able to inject any, well, configured value, like Spring has actually a similar feature. Something like, you know, a string, like, I don't know, string application version, for example. And I want, well, this would not work because then CDI complains that I don't have a producer for string, right? But what I can do is I can use an annotation config property that comes from MicroProfile config. And now I can configure that for a specific name, for a specific configuration key. such as version, and then I can use that with version in my code, wait for the reload, and then see, okay, now I have a configured version, 124. Okay, where does this version come from? That's weird. Well, MicroProfile config, you can have a look at that in the documentation, comes with a few default config sources that are especially helpful for modern, microservice applications. Things like environment variables, right? Very helpful for Docker containers or container orchestration, or property files. And this is actually where this comes from. That is the default convention, MicroProfile-config properties. Once you include that in your application, then while you configure in these properties this MicroProfile config, and you can make it easily injectable. And that's all there is. You don't have to do more. You can just add inject that somewhere in your managed beans and you're done. By the way, another nice feature of this plugin, it actually knows about this configuration location because it's a convention, so it will update that as well. Once you change the file, I just changed the property files, then it reloads this approach as well. So it's quite handy just to do this while you're coding. You don't need to restart stuff. You just write code, you change configuration somewhere, and then it works. Okay. If you don't have questions on that, I just continue with some other things. Metrics, monitoring, it's also quite important. Actually, all of these concerns are not that new, right? Things like fault tolerance, monitoring, health checks, it was always a thing, right? But once we are in a modern world with more microservices and more distributed systems, these aspects become, I believe, even more important. And it's helpful if we have some technology that enables us to do that in a little bit more pragmatic way, right? By just saying add config property and that's it. And I don't have to write a CDI producer method. I could, it's like 5 lines of code, whatever, but I also could not do it and just use that standard. Or MicroProfile metrics, that's another nice feature that is actually active per default. If I go to localhost/metrics, then what it will output, well, this looks a little bit weird. This is a Prometheus metrics format. You might have seen that. Prometheus is a de facto monitoring technology, and this format, that's line-based, plain text, it will just emit some metrics out of the box, like technical metrics out of the box for MicroProfile config for the JVM, for example. So how many loaded or unloaded classes do I have? Or, what is the memory consumption right now? What is the CPU and things like that? So these technical metrics might be helpful for production setting. Or what is actually more helpful for your business logic is to include some business metrics, right? So rather than telling technical information about your runtime, also include how many coffees have been ordered, how many cars have been produced, right? Some information that your business people care about that is emitted from these metrics as well. And what you can do then, you can also use some API. Since we include MicroProfile metrics, it also comes with a Java API that we can use. For example, I could inject some metrics, some counter, let's say, or some gauge, some histogram. There are different types of metrics. Or even easier, I could say, well, annotate a method with @counted, and then it will count the method invocations. For example, count the order coffee method to say what is name of the total number of ordered coffees, for example, right? So I could do this, reload immediately again, and then I have my orders. So I want to order some more coffee, right, to trigger this metric. 1, 2, 3. And then metrics will include a new metric application and so on and so forth. Coffee totals is 3, right? 3 ordered coffees. So again, it's just an easier way to define that in a declarative way. Of course, you could do the same with plain Jakarta EE, right? Having a JAX-RS resource /metrics and including that somehow in that same format, and then registering some counter like a CDI bean, like application scope bean, for example, and do the same thing. It's just a lot of boilerplate code that you would otherwise have to write yourself, and this is somewhat easier. And if you know about enterprise Java or even Spring, it's the same, you know, look and feel. It's the same development way of developing. Declarative approach, using annotations, very pragmatic to use. So this is what I like about these standards. Fault tolerance, another thing and we could talk about. Let's include some fault tolerance here as well. For example, there are a few fault tolerance concepts that are included that we could use programmatically here. Things such as timeouts, circuit breakers, bulkheads. Let's do circuit breakers in a bit. How do we write a circuit breaker? Well, we could write some interceptor, if you know about CDI interceptors API, that then has an interceptor class for the invocation of my method, right? And then if something goes wrong in the method, for example, typically an exception, then the interceptor can notice this, register, and then count for the number of exceptions. And if you have too many in a given time, you could, you know, fail the method and open the circuit, things like that. Or I just use the annotation at circuit breaker that comes with MicroProfile fault tolerance in this case, and say, okay, by the way, I have a request volume threshold, for example, for the last 10 invocations of this method. Have a look at whether this the failure ratio exceeds 30%, for example. And if that is the case, then open the circuit, right? Then don't invoke the method anymore, immediately throw an exception. Or wait for a delay for, per default, let's now change it to 3 seconds, and then the circuit is closed again, right? If I reload this, then I can do the same, and then, well, it works. I mean, I don't know. There is no error, right? How do we know that this works? Well, now since we have such a nice hot reload approach, actually what I can do, just for fun, for testing purposes, if new random, if we are lucky and less than 30%, throw an exception. Bam. Just because. Right? Why not? Let's see. Now let's order some coffee and, oh. 201 created. Oh, internal server error. Oh, that's bad. Right? So let's do this. Let's check for this and exception. Works, 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 works. Oh, didn't work. Okay. Let's do this a little bit faster. Oh, no, no, no. Oh, and now what we see. This is interesting. So I now did some invocations and it said, oh, in exception, exception, and then at some point, if it's too much, it immediately all the time throws exceptions, right? And now you see a different type circuit breaker, open exception. Now it won't even invoke the method anymore. Now it immediately will throw an exception. And then after 3 seconds, it tries again, and then the circuit is closed again, if that works. And it stays closed, and then, you know, depends on whether we are lucky or not. At some point, it will be open again, right? And then open, closed, open, closed. And then we see this circuit breaker work in real life. Okay, let's remove this again. Any questions? Now it works. So this is one example how we can use, again, a circuit breaker. So all of these things can be included since a long time with Java EE or Jakarta EE. It's just a little bit more pragmatic to use this Jakarta technology in combination with MicroProfile, which I believe is a very sophisticated way for modern enterprise projects. All right. Do you have any questions on that so far? Okay, then we can advance a little bit on the deployment side. So what I do here, basically, I told you before how to build this. And that Maven build should be as simple as that if you use Maven conventions. So I'm a big fan of using these Maven conventions that are built in, because then, well, it already comes with a lot of things. For example, we can run our tests. How do we run our tests? Well, in Maven, there are 2 default ways. One is called Surefire and the other is failsafe. Again, I'm just specifying the version here because of, well, Java version problems. Usually I could just leave that away, right? So with the default versions. And then what I can do, I can run some tests. Actually, we could write a test, basically hello world test, right? And then says, well, something like this, right? Assert true, always is green. So the point is, how do we run this test? Well, we run it either in our IDE or it will be executed as part of our build. Why will it be executed as part of a build? Well, because of the name. It's called hello test. That tells Surefire, okay, please run all the tests. What is wrong with my IDE? Why are you so slow? Now, there we go. And then this will be included. So if I say Maven clean package or Maven package or even Maven verify or Maven test, all of these phases will execute this test. Maven compiler plugin, okay, now it's really slow. This should be faster. Let's stop this in the meantime, so it executes actually faster. Yeah, way too slow. If you see a build time like this, then something has to change. In this case, the laptop was under load. Let's try this again, Maven package. So this will now do the compilation and run the tests, and in this case, it will run one test. Oh, where was it? Here. Because it's, well, a Maven Surefire test. What else I can run are so-called, well, integration tests. So this is what Maven includes per default out of a convention as well, and they are called IT, short for integration test. You can also have an exclusion or inclusion filter on what are considered with Maven Surefire or Maven failsafe, or you could just leave it and use the default. That's easier. So I call this CoffeeShop IT for integration test, and what it does, it's basically a test to, well, test my running application. So that's another thing about, well, testing is a whole different story. If you're interested in that, I can point you to some links and articles that I'm currently writing. But what this test is doing, it's basically testing, well, now I actually have to start this again. It's testing whether my deployed application is up and running. So it basically is a smoke test to use the same RESTful services here, RESTful endpoints that I use, to see, for example, whether the system is up and running, or to connect to the system and say, okay, give me, the coffee shop or this resource. Just a smoke test to see whether the system is up and running and does some basic check, right? So now, if that is the case, curl, let's do some test again. Let's order some coffee. Nope. That is up and running, launched. Okay, I think, or still some processes running. Let's see. Localhost, niet. Okay, let's stop this again. Might be something wrong with, nope, also no Docker container. Otherwise, what we can do, okay, let's try this again. And then what I want to do, I want to have a test that quickly connects to my application that is already running. So I showed you how you can run unit tests. How do you run these ITs? Well, you saw before this was not executed, right? When I just did the Maven package, I only had one test, not this test. Why? Well, it's a different phase that you call with failsafe integration test. So you can run that mode, again, per default. You don't have to include a specific and configure a specific Maven plugin phase. That just runs out of the box. If you specify this command, it will run my ITs, my integration tests. So now server has been launched. Let's wait for this. Then it will deploy my application. And then I can show you a little bit of more stuff. And then we can run the test against the application that is, well, currently being deployed. Okay, now it does this, order this. Still deploying. Okay, now we go. Come on. Laptop seems to be under load. 201 created. Now I can execute these tests. Let's do it first in the IDE. So what it does, it checks whether my system is up and running. And now again, my point is, you have to build up development workflows that are just very quick to execute, right? So the reason why I was using and why I like this plugin that I showed you is, well, it does its work fast, right? I just changed some code and you saw it 1 second later, there was the update. So now the same is true for these type of tests. They don't build up an environment because the environment is already running, they just test the environment. Why does the test fail? Well, it checks the version, whether the version is 1.2.4 like before. No, it's 1.2.3. Let's change this, and then I can re-execute the test, and then depending on how fast my IDE is, it immediately will say, okay, great, now your system integration test is green. I can do the same like I told you before in the command line. It just takes a little bit longer because Maven needs to start its process, and then it will do the same thing. Now it will not run my Surefire tests, it will only run the ITs, the integration tests, and then see, okay, this is green, this works. I can actually also run this Maven plugin. If I hit enter, it will actually run both my unit tests and my integration tests, so it's an extra feature, whatever approach you prefer, right? The point is you have to build up a test workflow that is just fast to execute, right? So, for example, if I change something in my code here, where's my health check resource? If I say, you know, rename this from version to app version, okay, it will immediately rename and compile it. And now, if I rerun my tests, then immediately I want the result that this, well, should now fail because it cannot find that specific version, right? And this is the workflow that I want. I go here and change something in the code, and application version, then it will just update this, and I can re-execute, where's my key? I can re-execute the integration test now in my IDE if I want, if that's fast enough, and then immediately I want to get a result, whether that is working or not, right? So that's a, well, 503, that's not what I expected. Let's rerun this again. And now this is, well, failing until I fix that again, right? So that is the point, having a quick verification on this side. Rerunning the test, and then I see, okay, now I expect the test to be green again. So I don't want to wait a long time. And I think the nice story is modern Java Enterprise enables you to do so. Okay, that's about testing. What else? There's another nice feature that I actually like about this plugin. How do we debug? Now you can say, well, insert some system out and some print statements. Well, that's one way. Or typically you would use your IDE feature, right? Your IDE debug feature, which you actually can do in a remote application. You probably know this, right? Remote debug, using a remote debug port. So that means you would have to restart your server in a specific mode, and then you can connect and pipe your IDE to that version. Using this development mode, you actually don't have to do that because it starts in a debug mode. So actually what it can do, and that's a nice story, just without changing anything that I have here, I can go and say, order coffee, set a breakpoint, and now connect my IDE and attach it to a process. And per default, it runs port 7777. I can attach to the port, and now I'm actually attached to my local running JVM that runs my OpenLiberty. And now if I say, go and order some coffee, now that request is captured, and I'm here in my IDE, and I can, you know, step through, step over, and run and debug, and see my variables and my watchers and see what is going on. So I can actually live debug what my HTTP request is doing, which is very helpful locally. Any questions to that? You're so quiet. That's either a good or a bad thing. Any questions? I have a question. Who used container orchestration before? Things like Kubernetes? Okay, a few. So then I won't show a lot too much. That is basically a way, so this should now not confuse you. It is basically the next step. Once you have things like containers, container deployments, then the question, how do you run these containers in a production environment, right? How do you run a Docker container? Well, you saw it before, Docker run, right? But I believe in production you have a little bit more than just a laptop, and nobody's sitting there and types Docker run. what you would do is you have a cluster of multiple machines, of multiple nodes that run somewhere, and then you have some sophisticated way of orchestrating them, right? You can build up your own orchestration, like your own sophisticated set of bash scripts to run them, and a lot of companies have done that. Or you use a more de facto standard technologies such as Kubernetes, and this is a way how to define that in the nice YAML file format that a lot of developers dislike. These are Kubernetes resources such as, this is a service, basically a load balancer abstraction over my CoffeeJUG application, and then the so-called deployment basically deploys individual containers, individual workloads, where I basically say, my application should do the following, please just run this following Docker image, right? In a somewhat sophisticated way. So without going too much into detail here, that is somewhat the next step, how to run our cloud native applications, because the nice story here is, it's again this notation of infrastructure as code. You specify as code what is the target state of my application environment, right? So this is the target state. I want to have one replica of my application, that means one instance, and in order to deploy it, use this Docker image and deploy it, right? CoffeeJUG, and so on and so forth. And just as a last demo, let's show you this. I actually have a Kubernetes cluster. If the Wi-Fi responds, this works. IKS is the IBM managed Kubernetes service. So it's a managed hosted Kubernetes provided by the IBM cloud. And I can then, use a command kubectl apply that applies this infrastructure as code definition that I have here to my cluster. And that, what it will do, once the internet works, it will deploy so-called services and deployments and what you just saw, and then it will actually ship and deploy my application to this cluster production, right? Nice story. Since this thin deployment artifact way of writing and deploying my applications is very much suited for containerized environment, right? You saw the Docker image, this copy and write file system. It really makes sense to make your deployment artifact small. That works really well together with this containerized environment. So it also works very well with container orchestration. So this is what we have here. And then if I ask for kubectl, get some resource, get the resource pod. What is a pod? It's an atomic workload. It's basically an abstraction over running container. And now I have that is my application instance that is running. And soon it's ready. It's, by the way, using these health checks that we wrote. Let's try this again. And once that is ready to do some work and up and running, and then I can actually access it and say, OK, now use, again, curl, right, HTTP communication, to use now secret script to get the cluster IP of my Kubernetes cluster. Now use this notation, CoffeeJUG again, right, /orders. And then once that is up and running, I hopefully have 200, OK, yes, resource, and then I can order coffee in the cloud. In the same application that is now deployed on my Kubernetes cluster that runs somewhere in the cloud, and I can say, OK, use this, right? So again, modern approach, quite easy to apply because all of that technology helps you. You don't have to write a lot of boilerplate stuff to do things that have been solved before. You just use modern technology in order to do that. So as some key takeaways from this, I want you to use some known technologies and APIs that are known to developers. And this is one of the advantages of a modern enterprise Java approach, right? A lot of developers have knowledge in how to do CDI, how to do JAX-RS, JPA, servlet, right? You've all typically seen that before. And in that modern approach, it's basically been updated for a modern world if you use Jakarta and MicroProfile plus some modern runtime. That really makes sense. And it enables you to focus on to solve business problems, right? Because all of the boilerplate stuff is provided for you, right? You don't have to write how to write HTTP handling and status codes and things like that, or how to access the database, well, it's done in a declarative approach, right? Using some annotations, done. And you can focus on, okay, what's the actual code, the business logic that I'm writing, right? And that combination, Jacquard and MicroProfile, I think is awesome. It's a great team, great technology. And what I also want to especially focus or emphasize is you should care about, well, if you have some existing investment or existing technology in enterprise Java, it makes a lot of sense to look into especially modern runtimes. So luckily, it has nothing to do with, you know, if you used old WebSphere or old WebLogic or things like that. Oh my God, nobody wants to use that. There are a lot of new modern runtimes or application servers, such as OpenLiberty, that, well, make it much more fun, much more effective to use these technologies, right? You saw that OpenLiberty or WebSphere Liberty, the new version, works the same way, runs very quickly, deploys fast. It comes with such a plugin that enables you to, well, develop really efficiently, and that is just a nice story. Or if you heard about Red Hat Quarkus, similar thing. It's based on Java Enterprise APIs, but the APIs are just this, just APIs, right? Set of annotations, set of interfaces, and then if you have a modern implementation, it can be really innovative and, you know, have new features, have some new cool stuff there, and just use, well, what solves business problems on the development side. That is what you should care about as developers. When it comes to tooling, please keep it simple and leverage the conventions that we have, especially with Maven. Like, delete all of that Maven XML that's there. You probably don't need it. That's probably a much easier way around to use it. Same with Docker. Very simple Docker files. Use the conventions and use, you know, features such as the caching, copy and write file systems, and that just makes it easier. And also very important, invest some time in proper testing and especially automation. And of course, CI/CD. That is always true. Like just that, these tests that I showed you was just a very basic way. If you take that approach further, you should, well, be able to test your application in a fully automated way that you can be sure that it works later on in production. So then you can have a well-defined process of a CI/CD pipeline to define how do you apply and deploy your application to a production setting. Similar what I typed in my command line, there should be a sophisticated process for that. Otherwise, I hope I could spark some interest in enterprise Java technology. Go check that out. You can check out some OpenLiberty guides as well. That's very interesting and I think fun to use runtime. I hope that was helpful. Thanks a lot for your attention.